This video is on percent composition, or the technical name would be percent composition by mass. That would be the complete name and what you might see in the word problem. Now, your equation for this is percent composition is equal to the mass of your element divided by the mass of your total compound. It's similar to any type of percentage. For example, your test scores is the number that you got correct out of the total possible points available to you. And in order to get it into a percentage, we multiply by 100. Now, your masses can either be a gram amount that it gives you for each element and then your total compound, or if it just gives you a formula and we're not given a gram amount, then we can use the molar masses. So it'd be the molar mass of the element we care about divided by the molar mass of the entire total compound. So let's see an example of both of those situations. This first one, a 10-gram sample, contains 2 grams hydrogen, 6.7 grams nitrogen, and 1.3 grams of oxygen. Determine the percent composition of each element. It gives us grams of 3 different elements, and it says we have a 10-gram sample. I need the percent composition of each element. So, for my percent of hydrogen, I want the mass of hydrogen divided by the total mass of my compound, or the total mass of my sample. So for hydrogen, I have 2.0 grams of my hydrogen divided by the total mass of my sample, which was given as a 10-gram sample. So I'm going to take 2.0 divided by 10 grams of my sample, multiply by 100, and that's my answer. So 2.0 divided by 10.0 equals 0.2 times 100 gives me 20% of hydrogen in my sample. Then I take my next element. So let's do nitrogen. Percent of nitrogen. I take the mass of my nitrogen, which is my 6.7 grams of nitrogen, divided by the mass of my total sample, divided by my 10.0 gram sample, times 100 to get it into a percent. So 6.7 divided by 10.0 equals times 100, and I get 67%. Equals 67% of nitrogen. Then, for oxygen, I have my 1.3 grams, so percent oxygen. I'm going to take 1.3 grams oxygen divided by my total sample, which is 10.0 grams of my sample, times 100. So 1.3 divided by 10 times 100, I get 13%. Now, I've got percentage for all of these. If I wanted to check my answer, what I would do is I would add all of these up, and they should all add up to 100. So 20 plus my 67 plus 13 gives me 100%. Perfect. Now, if these were, when I calculated it out, it gave me like 20. There were no other decimals. If I had used probably something a little bit harder than 10 grams, it would have worked out a little better. Excuse me. Round to 2 or 3 decimals. So I would have taken like 20.0% or 20.00%. I would like you to give me more than just the 2 digits. Give me some type of decimal, because that's generally what you see percentages in. Now, that's if we're given gram amounts of our samples and each element. If we are just given a compound, so for example, determine the percent composition of oxygen, in CaNO3 parenthesis 2. For this, I have to look at the molar masses. So same idea, it's still the mass of my element, but now I'm looking at the molar mass of the element I care about. In this case, it asked for oxygen. I could have asked for calcium. I could have asked for nitrogen as well. Now, then I divide by the mass of my total compound, which is the molar mass of my entire compound here. Now, the reason why it went so dark was because my lights turned off, but if I pause this video, then I have to do another part, so I'm just going to keep going, and I hope you can still see. So, I need the mass of my oxygen, and I need the mass of my total compound. I'm going to start by taking the molar mass of my total compound, because then that's one less calculation I have to do. So I have 1 calcium. Calcium has a mass of, on the periodic table, 40.078. Nitrogen. Okay, this 2 on the outside of the parentheses carries into the nitrogen and it carries into the oxygen. So I'm going to multiply that into everything inside the parentheses. So my nitrogen, instead of just 1, I now have 2 nitrogens. Nitrogen has a mass of 14.007. Oxygen, I had 3 inside my parentheses. The 2 multiplies into the parentheses. It multiplies in, so instead of 3, I have 3 times 2, which is 6. I do not add those together to get 5. I multiply them to get 6. Oxygen has a mass of 16. Okay, if I plug this into my calculator, 1 times 40, well, that gives me 40.078. 2 times my 14.007 gives me 28.014. And then my 6 times my 16 for oxygen gives me 96 for just the oxygen. And then to get my total molar mass, I'm going to add all of those numbers up, 40.078 plus 28.014 plus my 96 gives me 164.092 grams per mole for my entire compound. Now, it had asked me for the percent composition of oxygen. So if I want the percent of oxygen, I need the mass of oxygen divided by the mass of total. I have 6 oxygens. So I don't just use the 16, but I use the fact that I have 6 of them as well. So I'm going to put this 96 number. That's my molar mass of my oxygen. That's the mass I use on top. I'm going to put 96 on top. Then I divide that by the total mass of my compound, which is what I just figured out to be 164. I multiply by 100 to get it into a percentage. So, 96 divided by 164.092, 0.585 times 100 gets me 58.50% of oxygen. Because it only asked for oxygen, that's all I need. If I had wanted percent nitrogen, then I would have taken this mass of nitrogen, my 28.014, divided by my total mass of my compound, the 164.092, times 100, I would have gotten 17% nitrogen. Sorry, you can't really see that. There we go, 17% nitrogen. And if I had wanted percent calcium, I would have taken the mass of calcium, the 40.078, divided that by my total, 164.092 times 100. I would have gotten 24.42% calcium, and that was a 17.07% nitrogen. To check my answer, I should add all of these up to get a total of 100%. So 58.50 for oxygen, plus my 17.07 for nitrogen, plus my 24.42% calcium, and I get 99.99, which is really close to 100%. That's one way you can check your answer. Again, these two weren't asked for. You have to show me all of your work. Do not just plug it into the calculator like I just did. But I hope that was helpful. Good luck studying for your test.